Welcome to this video on the activity component in Android. We will also learn about the activity lifecycle, how to add, collect and view logs, and how we can use the build variant to automatically disable or enable our log. So let's get started. Okay, so open up your studio and open your thumb5 project if it is not open. Let us go to main activity.kotlin. It should be under your app Java package. Main activity is the first activity that our app is launching. So every screen in Android phone corresponds to an activity. In our case, it is the main activity, which is defining the layout through this activity_main layout file. The layout can also be defined by fragments, which are hosted by the activity. More on these fragments later. For now, we will limit our knowledge to activity. So let us just check what all code has been written in this activity file. At the top, we have the package name, which tells us where exactly this file is placed in the folder structure. This corresponds to the Java package name. And then we have the imports, just like a Java file where we are importing the app compact activity from the Jetpack library and also the bundle class. So app compact activity is an activity file or activity class defined by Jetpack library, which helps us consume features which might not be available in the API that the phone is running. So suppose my phone is running a KitKat version. There are some features of the action bar and navigation which are not available in KitKat phone. But if I use an app compact activity, those features will be available to my activity class. So this actually helps Android get over the fragmentation or get over the slow updates that are a problem for the Android ecosystem, because the Android manufacturers don't update the Android phone as soon as a new version is released by Android. The features are not available for all developers or for all phones. So this Jetpack library ensures that all those features can be consumed by all the developers. So now more on this Oncreate function. So this Oncreate, you can say, is the entry point to this activity. So as soon as the activity is launched by the phone, when you click on the launcher icon, this activity will be launched and this Oncreate method will be called. In this method, we will set the content view as activity_main, which can be found under the R file, under layout, and then activity_main. So R file is nothing but the resource file auto-generated by the Android code. Anything that you define under the resource folder or RES folder will be mapped to some entry under the R file. So you can see we have these two drawables, our IC launcher background and foreground. So if I do the drawable, I can find those two entries. So using this R file, I can easily link to those images defined under the drawable folder. Likewise, we also have mappings for strings and also for colors. By clicking on that, you will be directly taken to the colors file. So for every activity, there is something called the activity lifecycle. Because we are only allowed to write code in our activity, we don't know when the user has gone out of the activity to attend a phone call, or when he has switched to another app, or when something else is being displayed over our app. So these activity lifecycle methods, so if I go to activity lifecycle page on the developers android.com and scroll down to activity lifecycle, these are all the callback methods that are defined by the Android, which we can use to figure out where exactly our app is and how the user is interacting with us. So as soon as the activity is launched, as we saw, the entry point Oncreate method is called. Then we have the onStart method and the onResume method. After that, we know for sure that our activity is running and it is in the foreground and it is being displayed to the user. As soon as something comes up over our activity, the onPause method will get called. If the activity is no longer visible, something like another app, then the onStop method will be called. And if the system or the phone decides to kill our activity, or the user swipes your app out to kill it, then the onDestroy method is called. But if the user does not kill your app and he's chooses to come back to your app, then we will have this on restart method, which will go to on start and then on resume again. So a little bit of theory. So let us try to do a practical for these lifecycle methods using the log function. So let's go back to our activity and use the log method. So this log class is defined by Android to print you can say log messages or debug messages, which you can use to identify what is going on with your app. So not every time while developing your app or while the user or the QA team is testing your app, you will not be able to figure out what is happening. So these log messages will help you figure out how the user interacted with your app and where exactly things went wrong. So there are different levels in the log files. So starting with verbose, and then debug, then info, warning, error, and assert. For most debugging part, we will be using the debug messages, and to log errors, we generally use the error message. Now the method, as you can see, takes two parameters. First is the tag, and the next one is the message. As you can see, you can use the tag to identify the source of a log message, like the class or method or activity. And then the message, as it says, will be the message that you would like to be logged. So let us create a constant to denote the tag. We'll just use the activity name. And in the message, we will just print the name of the lifecycle method. So let us override all the other lifecycle methods and put the log message. So we have overridden all the lifecycle methods and put a log message in all of them. So let us just test it out. So if I see here, my activity is shown, and if I go to logcat, I can see that there are a lot of messages being printed. Some are from my package and some are from other applications. So if it is not filtered, please choose show only selected application and then come here and select your application. We can put the default filter for debug. And then we can type our tag so that we will only see the log messages that we are interested in. So you can see as soon as the activity was launched, Oncreate, Onstart, and Onresume were called, just as shown in the activity lifecycle. So now if I press back, I can see that the onPause, onStop, and onDestroy are called, which means that the activity has been killed by the Android. Now, if I click on my app again, then again we see that Oncreate, Onstart, and Onresume are called. Now if I don't press back, but I just switch to another app, I can see that only on pause and on stop are called. Okay. So now if I switch back to my app, I can see that on restart, on start, and on resume are called. So this is how you can get to know in code how the user is interacting with your app, and you can use the on pause and on stop methods to clear out some memory or to stop some task that you might not want when the user is not interacting with your app directly. Then again, you can use onResume to restart those background tasks. So now one more thing on log. If I leave these log messages as is, these log messages will also become a part of the APK or the binary that the end user will be using in his own phone. So if I'm printing some sensitive data in my logs, it might end up getting printed in his logs, and that might create a security issue for him. So generally what we do is we use something called build variants to define whether the logs have to be printed or not. So if I click on this build variant button on the left side in the studio, this build variant window will come up, which allows me to switch between the build variants. So I can see there are two build variants, one is debug and one is release. Now these are defined in the Gradle file, which we will check later. So if you click on the second build.gradle file, which says module and not the project, thumbfight.app, we can see here that we have defined the release build. By default, every app will have the debug build, and we have defined one more build type, which is the release. Now generally all your debug builds will be debuggable, which means that I can use the debug app or attach the debugger to debug my code. But if the build type is released, I will not be able to do that. So more on build types later. For our log purposes, generally what we do is if build config.debug, then print the log, which will ensure that only when the build is debugged, my logs will be printed. So now if I switch my build to release, might take some time. Oh, I've rebuilt the app. I can see that the build config has been generated again. So now if I go to debug, I can see that it is false. If you ever want to see logs in the release build, then you will have to go everywhere and enable the logs. So generally what we do is, let's go back to the Android view and create one. I'll just create an interface, I constants, and create a companion object for the static access, and just write val log enable equal to true. And then I will use this as the flag for all my log statements. So instead of having to go and change everywhere, I can just go to one place and enable and disable logs. So for the default thing, what we can do is I will just so just to ensure that I don't print logs in release build, for now I will just leave it to build config.debug. Giving an error, so whenever you change the build variant, please remember to rebuild your project. Otherwise, all the auto-generated files would have been deleted, and then they will just show error. So yeah, build config file has been regenerated. It is debug, so it will be true. And then we have also put our log statements properly. So this is it for this video. In the next video, we will try connecting our UI that we built earlier to our code, and then learn how to respond to events when the user clicks on the buttons, and how to update the UI whenever this code changes. Thank you for watching.